I am going to explain about total probability. Total probability is used to find the probability if two or more companies' data is there. I will tell you one example here. For example, here the box one is having two white balls and three red balls are there. Three red balls. And then in this case, directly we can calculate, I am assuming probability to get red ball. Probability to get red ball. If it is single box. So there are favorable outcomes by total number of outcomes is the formula. So how many red favors are there? There are three favors are there out of 3 plus 2, 5. This is for single box or single company data. But if one more box is there in the same sample space, for example, here box 2 is also there, box 2, and it is having that is 3 white balls and 4 red balls are there. So this is also in the same sample space. Same sample space if it is having. Then here this is the same sample space. In this case, what is the probability? If we select one randomly one ball, then what is the probability to get red ball? Then according to total probability, we can say that that is box 1 probability plus box 2 probability to get red ball. That is the total probability. Box 1 probability plus box 2 probability. Box 1 probability is what? That is probability to get red ball. There are 3 red balls are there out of, here you can see this in box 1, 3 red balls out of 5 multiplied with box 1 selection probability 1 by 2. Because if two boxes are there, B1 and B2, then probability to get selection 1. If you select one ball, it may come from box 1 or else it may come from that is box 2. So that's the reason here the probability to select box 1 probability is there is only one favor out of two favors. Similarly, probability to select box 2, there is a one favor out of two outcomes. Plus, what is the probability to get box 2 to get red ball? There are 4 red balls out of 4 plus 3 7 into box 2 selection 1 by 2. That's it. So this is the total probability theorem. I will explain the proof again. Here you can see this. If two or more boxes are there or two or more companies are there, we can go for the total probability theorem. Here you can see this to explain that the proof, if you want, you can here there is a sample spaces and it is having mutually exclusive events B1, B2 up to Bn are there. Bn. So and in the within the same sample space A is also one of the event. Then the total probability theorem we need to prove. That is total probability theorem P of A is equal, that is sigma I is equal 1 to n P of A by Bn multiplied with P of Bn. P of Bn. So if two boxes are there, that is box 1 plus box 2. P of A by Bn into P of B1 plus P of A by B2 into P of B2. So coming to the proof, we can say this B1, B2 are the mutually exclusive events. Means we can write it as B1 union B2 union up to Bn is equal sample space S. Or else you can write it as S equal union of n equal 1 to n Bn. And consider one more to prove that easily. Consider that is A intersection S is equal to A. Because B1, B2, Bn are the mutually exclusive events. So for example, A is having 1, 2, 3 elements, 1, 2, 3, intersection. S means I am assuming 1 to 10. So now what is the common intersection points? 1, 2, 3 only. So means A only. So take the probability both sides, then you can write it as P of A equal P of A intersection S. And S is what here? P of A intersection. S means, you can see this S means B union of n equal to 1 to Bn. So we can write it as that is union of n equal to 1 to n Bn. So take it outside union and that can be written as sigma 1 equal to ntn P of A intersection Bn. But according to conditional probability, we can write it as what? P of A intersection Bn equal P of, that is sigma I is equal 1 to n P of A by Bn multiplied with P of Bn. That's it. So this is the total probability theorem. If two or more boxes are there, we can go for the total probability theorem to calculate the probability. So this is the proof. You can see this. That's the reason box 1 probability plus box 2 probability. So here this is the total probability theorem. Thank you.